So more on velocity of acceleration and applications in general. Um, Again, the derivative finds the instantaneous rate of the change of the function, which is the velocity of the function. It's the speed, that's the number, how big. So if the derivative is 2, 2 is the magnitude, and the direction was whether it's positive or negative. So I'm increasing, I'm going up. Or if it was a negative 2, 2 would be the speed. The negative tells me I'm decreasing by that speed. Right? Again, it follows the limit definition of the derivative. It's the rate of change. Average rate of change is the limit of the average rate of change is velocity. It gives speed and direction of object. Typically, if it's a free-falling object, if it's moving up, or a projectile, if we're shooting it out of a cannon, or I have an example of a balloon being launched from a treehouse. If it's moving up and to the right, we consider that positive directions. It's moving down and to the left, we consider those negative directions. Right? That's just the standard directions. Acceleration is the rate of change of the velocity. Right? It's the second derivative of the position. And again, it's just found by taking the second derivative of velocity. It gives me the acceleration. Alright, so to do a simple example, it's the water balloon one I kind of talked about. So suppose I have a water balloon launcher, so you've got like a slingshot or something. It's been installed in a tree house 12 feet above the ground. The equation h of t gives the vertical height, so that's the distance the balloon is from the earth, right? That's the vertical height. So, it starts out at time 0, it's at 12, right? That's where it is. And then it's launched, and then it comes back again due to the gravity will pull on it, and it'll come back down to the earth. So again, I have sort of a parabola-like shape. Right? That's why it's a quadratic equation. All right, find the equation for velocity and acceleration, give the units. And so remember, velocity is the first derivative. Right? It's the h prime of t. And so it would be the change in my height over the change in time. And that kind of helps you out with the units. All right, so finding this, first the derivative, so it's just negative 12t plus 32. The units would be the change in the height. Well, the height is in feet per change in time. Well, time is in seconds. And so the units would be feet per second. All right, and that's the simple form. You could write feet per second if you want to. All right, acceleration is the second derivative. It's the derivative of the derivative. So I'm looking at my derivative, and I take its derivative. And so it comes out negative 12. Right? It's the derivative of the height with respect to time, second derivative of the height with respect to time twice. And so it's the change in the height with respect to time twice. And so the units on it are feet per second squared. That's the acceleration. Feet per second squared. So it's decelerating, right? The pull of gravity and friction and whatever is pulling on it by negative 12 feet per second squared. Alright, so the velocity of the balloon, so I want to find the velocity of the balloon at 2 seconds and 4 seconds. Alright, so velocity at 2, which again is my derivative at 2, and the velocity at 4. The derivative at 4. So again, I go and use my derivative equation, so I use this first equation here. Alright, and at what time is it moving at a faster rate? So which time is it at a faster speed? Alright, so I'm just going to plug it into that negative 12t plus 32. So when I plug 2 in, I'm going to get negative 12 times 2 plus 32 is going to give me 8 feet per second. Let me double check that. Yep, all right. Positive, and it's positive 8, so that means it's moving upward, so it's still going upward. So it's still traveling up, further away. It's getting further away from the Earth, so it's still in the upward arc. All right, when I plug 4 in, that's going to be negative 12 times 4 times 6, so that's going to come out negative 16 feet per second. And so now it's arced, and it's turned around, and now it's coming back to the Earth, and it's actually downward. All right, so this one is still moving away from the Earth. This one is coming back down to the Earth. And this is the negative is just telling me the direction. The 16 is the speed. So at 2 seconds, it's got a speed of 8 feet per second. At 4 seconds, it's 16. It's twice that. And so it's moving twice as fast after 4 seconds. Alright, so it's faster after 4 seconds. Alright, at what time is the velocity of the balloon -9 feet per second? So this one's giving you the velocity. So I know I'm moving in the downward direction. It's supposed to be around 3 decimal places. That's the wrong 2 there. Alright, at what time? So I want to find my time. My velocity, which is my first derivative, is equal to -9 feet per second. And so I take my velocity equation, set it equal to -9, and solve for time. Alright, so my velocity equation was -12t plus 32, and I want to know when does it equal negative. And you do have to include the negative, because that's important. It's important that it's moving downward, not upward. And then you solve for t. So I'm going to move my 32 to the other side. So -12t equals -41 divided by my -12. And so t is exactly 41 over 12, but now I'm going to round it 3 decimal places. So 3.417 seconds. Alright, so it's at a speed of 9 feet per second moving downward after about 3.4 seconds, 3.417 seconds if I round 3 decimal places. Alright, so that's the acceleration and velocity. So I'm going to pick up the next examples talking about finding tangent, because it's going to be important that we can find tangent lines that are horizontal, and I'm going to do that in the next video.